welcome. Today we're talking about parabolas again, and we're coming up with a new definition of exactly what a parabola is. So, take a look at this. If I have a point, let's make this big green point right here, and I have a line, which is this red line right here. Okay, I'm going to draw it in green. Okay, that's my line. If I were to find all the points that are equidistant between the point and the line, I could put them in. This distance is equal to this distance. This point becomes it. This distance is equal to this distance. That point's part of it. This distance is equal to this distance. That point is part of it. If I were to trace or connect all of those points, I would end up with, sorry, I can't see my color changer. I would end up with this shape. This is badly drawn, I know, but it's a shape you're very familiar with, which is parabola. So a parabola is the shape that's formed by all the points that are equidistant between the point and a line. Okay? I'm going to skip through some of this. Take a look here. Here's the parabola. The point we were talking about is a new vocabulary word for you. That's the focus. The line we were talking about is the directrix, another new vocabulary word. All these points are equidistant. This particular drawing is not drawn to scale at all. Okay? All right. If you take your vertex of your parabola and you put it on a coordinate grid, we say that the coordinates of that vertex are h, k. Okay? Now, the distance, we call it the focal length, between those two, between the vertex and the focus, should be the same as the distance between the vertex and the directrix. That's the focal length. And that focal length is 1 over 4a. So think about it. The coordinates of this focus point up here are going to be h, because the x-coordinate's not changing, comma, k plus 1 over 4a. The equation of this directrix is going to be y equals k minus 1 over 4a. K minus 1 over 4a. Okay? You don't have to memorize these equations. Just remember it's going to be 1 over 4a below whatever the vertex is. Okay? The axis of symmetry is going to be x equals h, because all the points on that line have h as its x-coordinate. One more term here is the latus rectum. That's the segment that attaches to both sides of the parabola, passing right through the focus. The length of that latus rectum is 1 over a, absolute value. Okay? Let's see how we can apply this. Here we have an equation that's in vertex form. What's the vertex? 2, 3. The 2 comes from right here. That's our h value. This is our k value. Okay? The axis of symmetry. We did this last night. X equals 2. The focal length. That's the 1 over 4a equals, what is a here? 1/4. So 1 over 4 times 1/4 is the same thing as 1. So now it gets a little tricky. We want to find the focus, the coordinates of that focus. Well, the x-coordinate of the focus is going to be the same as that of the vertex. So that's just going to be 2. The y-coordinate of the focus is going to be this value plus the focal length. That's going to be 4. Now let's take the directrix. The directrix is it's an equation equation of a line, so we're going to call it y equals, and you know what? I'm going to see if this helps you to figure it out. Let's put the vertex in here. 2, 3. There's the vertex of the parabola. The focus is at 2, 4. That's the focus. We know our parabola opens up like this. Remember that the vertex is going to be halfway in between the focus and the directrix. So is it obvious that this is the directrix right here? So the directrix is going to be y equals 2. You can figure that out by saying it's 3 minus 1. Okay, LLR stands for the length of the lattice rectum. That is absolute value of 1 over A. A is 1/4, so 1 over 1/4 is the same thing as 4, and the absolute value of 4 is just 4. Okay? That's going to help you because look, when we come to actually graph this parabola a little bit better, let me put my vertex back in here. The lattice rectum goes right through the focus, and if it's equal to 4, that helps me to know, and that gives me 2 points on my parabola, and I know how shallow to make it. Let's try another one. Here we've got vertex form already, so our vertex is at, oh, it's not quite vertex form, is it? Let's change this into negative x minus 3 squared plus 1. So the vertex is at negative 3, 1. The axis of symmetry is x equals negative 3. So let me negative 3, 1. The axis of symmetry is right here at negative 3. The focal length, 1 over 4a. Okay? What is a? A is negative 1. So this focal length becomes negative 1/4. So the focus becomes negative 3. We know it's still on that axis of symmetry. It's negative. We take 1 plus negative 1/4 becomes 3/4. So I'm going to negative 3, 3/4. There's my focus right there. Directrix. Well, that's going to be just the opposite side. It's going to be 1 plus 1/4, or 1 minus negative 1/4. Y equals 5/4. And I know that this opens down. The length of the lattice rectum is going to help me figure out how to graph that well. It's a little hard when it's so small. But 1 over A absolute value equals, in this case, negative 1, which is just the same thing as 1. So I know that this is the length of the lattice rectum. This is my parabola. All right, let's try another one. Okay, this one, here's the problem. It's not in vertex form right now. So first thing we have to do is change it back into vertex form. X minus 6 squared minus 24. Divide both sides by 6, you end up with 1/6 times x minus 6 squared minus 24. All right, what's the vertex going to be? Vertex is going to be 6. Sorry. When you divide both sides by 6, you have to divide the 24 as well. So this should be negative 4. 6, negative 4. All right, the axis of symmetry is going to be x equals 6. Let me go ahead and graph that much. 6, -4. There's my vertex. I know the axis of symmetry is right here. The focal length is 1 over 4a. A in this case is 1/6. So 1 over 4 times 1/6 becomes 6/4, which is the same thing as 3/2. All right, the focus here becomes, let's see, well, the x-coordinate stays the same. The vertex is at -4, and the focal length is 3/2. This one's opening up, so we're going to end up with -4 plus 3/2, which is -2.5. Okay, just leave it as a fraction, or leave it as a decimal. So let's put in the focus here. It's going to be 6. -2.5 is right there. That's my focus. Okay. Well, the directrix is going to be the same length on the other side. So this should be the directrix right here. And I know this is opening up. The focus is always on the inside of the parabola. The directrix is behind it. The equation of the directrix would be y equals -5.5. The length of the latus rectum is 1 over a, absolute value of. A is 1/6, so this becomes 6. So I go up here to the focus, go 3 over on one side, 3 over on the other side. That makes 6 altogether. Now I can sketch my parabola pretty easily. Right there. Got 3 minutes left on my recording, so let me try one more problem. First, I have to put this into vertex form. Okay? So think, I'm going to pause it, put it into vertex form, and then you can check and see if you got. All right. This is the vertex form that I ended up with. So your vertex should be -16, 15. Now I can't graph that here because I don't have enough, so I'm going to count each space as 2. And I'm going to go ahead and put this, oh sorry, your vertex is at +16, 15. So 2, 4, 6, 8, 10, 12, 14, 16. Go up 4, 6, 8, 10, 12, 14, 15. Here's my vertex right there. The axis of symmetry is x equals 16. The focal length is 1 over 4a. If I plug in 1/16 here, your focal length should be 4. Actually, your focal length is -4 because a is -1/16. So next, we're going to count up or down 4. Yeah, this one's opening down, so we're going to count down 1, 2, 3, 4. Okay, there's the focus. The focus is at 16, 15 minus 4 is 11. The directrix is going to be up 4. 1, 2, 3, 4. Here's the directrix. Hopefully you can make a better line than I can. Okay, this is going to be y equals 15 plus 4 is 19. The length of the latus rectum, absolute value of 1 over a. That's the absolute value of 1 over -1/16, which is the same thing as the absolute value of -16, which is the same thing as 16. So what you're going to do is you're going to count out 2, 4, 6, 8 on this side. Oh, sorry, I should do it down here where the focus is. Your parabola is going to go right through that point, and on this side the other way. All right, good luck with those.